Today we're going to continue talking about graphs of other trigonometric functions. Now, we've already talked about graphs of tangent functions, so today we're going to be talking about graphs of cotangent functions. Now, period remains the same at pi over b. What changes is the vertical asymptotes. We want to set them equal to 0, and we want to set them equal to pi. And when we do that, that's when we can find our vertical asymptotes for cotangent graphs. Now, if you look right here, all the information is already in your notes, but you'll see that the domain is not at values of pi. X-intercept is at pi over 2 plus some value of pi based on phase shift. There's no y-intercept. It never crosses the y-axis on the parent function. And we can try one of these now. So if we look right here, locate the vertical asymptote and sketch the graph of y equals cotangent of x divided by 3. So first we want to find the period. Remember, period is pi divided by the absolute value of b. Well, another way to write x divided by 3 is 1/3 x. So this is really just the same as pi over 1/3, which remember reduces to 3 pi. So from 0 to 3 pi is going to be one of our periods. Now we want to find our vertical asymptotes. So we'd say x over 3 plus 0, we don't even have to put that in there, is equal to 0, and x over 3 plus 0, don't have to put that in, is equal to pi, because remember we want to set them equal to 0 and pi. So I multiply both sides by 3 here, and we get x equals 0. Multiply both sides by 3 here, and we get x equals 3 pi. So our period is 3 pi radians, and my vertical asymptotes are going to be at 0 and 3 pi. So let's make a table of values. Let's first look at just cotangent of x. Remember, our vertical asymptotes are generally at 0 and pi. And so halfway between it would be pi over 2, and then we get pi over 4, and 3 pi over 4. And so then our values would be, well, at 0 it's going to be undefined. At pi over 4 is going to be 1. At pi over 2 is 0. Negative 1. Then back to pi is undefined again. So this one, instead of going down and up like a tangent graph does, this one starts at 1, goes to 0, and then negative 1. It's going to be a downward slope. Okay? So let's look at what our table looks like for cotangent of x over 3. So first we want to find our x values. So again, my vertical asymptotes are at 0 and 3 pi. And those are undefined values. Okay? Now halfway between 0 and 3 pi, you find the midpoint. 0 plus 3 pi is 3 pi divided by 2 is 3 pi over 2. Then halfway between 0 and 3 pi over 2 is going to be 3 pi over 4. And halfway between 3 pi and 3 pi over 2 is going to be 9 pi over 4. So at 3 pi over 4 we start at 1, then 3 pi over 2 is 0, 9 pi over 4 is negative 1. Okay, so now that we have a table of values, we can sketch a graph of our cotangent function. Okay, so obviously here's 0, and then let's say that's 3 pi. Okay, halfway in between it is 3 pi over 2. That's going to be 3 pi over 4. 9 pi over 4. Okay, vertical asymptote is going to be at 0. going to be at 3 pi. My x values, my y values, at 3 pi over 4 I'm going to be at 1, at 3 pi over 2 I'm going to be at 0, and at 9 pi over 4 I'm going to be at negative 1. So my graph's going to look like this. And we could continue going on both to the left and the right of my vertical asymptotes. There's a couple, 3a and 3b, examples. You could stop the video now and try those. Okay, so we've talked about tangent, we've talked about cotangent. Now what we have to talk about are cosecant and secant graphs. Now, what I want you to notice is, here's a sine graph right now. And you'll notice that my cosecant graph meets at like the top and bottom, the maximum and minimum values of it, and it just basically makes like a parabola between the vertical asymptotes from those values. It does the same in our secant graph as well, just cosine is obviously moved over based on the values of cosine. So we're going to use that information that we know from this to figure out the graphs of secant and cosecant functions. So here's the properties of them. Obviously we don't have to hammer through all of them, but you'll see again that they look very similar to each other, just like sine and cosine graphs do, just shifted a little bit. Alright, so it says locate the vertical asymptotes and sketch the graph of the following function. Well, we go back and we need to know again what the period is for these values. Now again, how did we find the period of sine and cosine functions? Well, the way we found the period again was 2 pi over the absolute value of b. So in our case, b is going to be 1. So 2 pi over 1 is just going to be 2 pi. So again, my period of my cosecant graph here is just 2 pi. So now what I'm going to need to do is find my vertical asymptotes. So what I do is I'm going to set this value right here, x plus pi over 2 equal to negative pi, and I'm going to set it equal to positive pi. Okay, so now I just have to solve these problems. How do you undo adding pi over 2? You subtract pi over 2 from both sides. And you'll see that x is equal to negative 3 pi over 2. If I subtracted pi over 2 from pi, I find that x is equal to pi over 2. So my vertical asymptotes are going to be at negative pi over 2 and pi over 2. So let's make a table of values. Well, let's first look at what just cosecant of x looks like. Remember the values that we found important before, what we said our values equal to was negative pi all the way to positive pi. Halfway in between there is going to be 0. And halfway in between negative pi and 0 is going to be negative pi over 2 and a positive pi over 2. And the values I get for these is undefined, because remember we have to make some sort of parabola, and then undefined here. So these ones for cosecant and secant graphs are going to have 3 undefined values. And so at negative pi over 2, that's going to be negative 1, and at positive pi over 2, it's going to be a positive 1. So that's where our parabolas up and down kind of come from right there. So now let's look at the graph, or the table of our graph. So x plus over 2. Right? So we said my vertical asymptotes are at negative 3 pi over 2 all the way to pi over 2. Okay? Halfway in between there is going to be pi over 2. negative pi over 2. Okay, halfway between negative 3 pi over 2 and a negative pi over 2 is going to be negative pi, and halfway between negative pi over 2 and pi over 2 is going to be 0. So what are my y values then? Well, we said they're undefined, negative 1, undefined, positive 1, and undefined. And so now we can use this right here to sketch our cosecant graph. Okay, so we had negative 3 pi over 2. We had negative pi. We had negative pi over 2. We had 0. And then we had a positive pi over 2. Okay, so my vertical asymptotes again are going to be at negative 3 pi over 2, negative pi over 2, and a positive pi over 2. Okay, so at negative pi over 2, my value was negative 1, so it's right here. And at 0, my value is a positive 1. So then, obviously, my graph is just going to be a parabola between these undefined values. Right there. And we could continue. Obviously, you'd see that right here would be my other side. And then right up here would be another parabola going up. Okay, so it just alternates between up and down between our parabolas. Last question. Y is equal to secant of pi over 4. Okay, so period again is going to be 2 pi over b. Our b would be 1/4. So then 2 pi divided by 1/4 is 8 pi. So it's going to take 8 pi radians to make a whole period. Okay, so to find our vertical asymptotes, I'd say x over 4 plus 0 is going to be equal to negative pi over 2. And x over 4 plus 0 is equal to positive 3 pi over 2. So I solve for x on both sides, multiply by 4, and I get x equals negative 2 pi. And over here I multiply by 4, and I find that x is equal to a positive 6 pi. And so you'll notice that obviously the period is 8 pi, because from negative 2 pi to 6 pi is 8 pi. So let's make a table of values here. So we want to start at negative 2 pi. We want to go all the way up to 6 pi. Halfway between 2 pi and 6 pi is going to be 2 pi. Halfway between negative 2 pi and 2 pi is 0. And halfway between 2 pi and 6 pi would be 4 pi. Okay, so I have to figure out my y values. Well, again, just like, or almost the opposite of cosecant, okay? Undefined, undefined, and undefined. But now instead of going to negative 1 first, we go to positive 1 and then negative 1. So if I'm going to sketch my graph, okay, here's negative 2 pi, 0, 2 pi, 4 pi, and 6 pi. My vertical asymptotes occur at negative 2 pi, 2 pi, and 6 pi. And at 0, I'm at a positive 1, and at 4 pi, I'm at a negative 1, and the parabolas are right between the asymptotes. If I needed to continue, obviously, this one over here would be down here, and this one would be right here. Here's 2 problems you can try as guided practice.